Hi, and welcome to this first video in a series on probability taken from the applied statistics section of the course. And what we're going to do in this first video is go through some very basic probability ideas that you'll have seen before at GCSE, which you might want to kind of skip through fairly swiftly, but there is some important definitions, particularly with regard to those two things you can see on the screen at the moment, which is mutually exclusive and independent. So what we're going to do is essentially look at kind of what those two things mean. So here we go. Right, first example I'm going to use is taken from a pack of cards, and if you're not familiar with how a pack of cards work, you've got red cards, black cards, you've got four suits, hearts, clubs, diamonds, spades, and for the purposes of these examples, I'm going to be referring to a picture card as just Jack, Queen, King. I'm going to regard the ace as being just a normal number card. Okay, so here we go. First of all, probability that we've got a red card. Clearly 52 cards in the deck, excluding the jokers. We've got 26 red, because we've got 13 hearts, 13 diamonds, and so the probability that you get a red card, 26 over 52, or half. Fairly straightforward. Likewise a spade, probability we get a spade. We've got 13 spades in the deck, so the probability we get a spade is 13 over 52. Picture cards. So picture cards, we've got Jack, Queen, King in each suit. So we've got four suits, that's 12 cards, so the probability we get a picture, 12 over 52. And then either a red or a spade. So we've got the red cards, which are 26 over 52. We've got the spades, which is 13 over 52. Add the two things together, so we've got 39 cards altogether that are either red or a spade. And we get 39 over 52. And so all we're doing there really is just simply adding those two probabilities together. And the point I really wanted to make with all of this is that if we get those two events, getting a red and getting a spade, they're referred to as mutually exclusive, which basically just means they've got no outcomes in common. It's not possible to get a red card that is also a spade. So there's no way you can pick one card and have both of those outcomes occur. And if we've got two events that are mutually exclusive, then what we get is the probability of A or B, either of those things happening, is simply the result of just adding together the two probabilities. Now that might seem fairly obvious in this simplistic example, but we need to be careful when we're thinking about whether events are mutually exclusive or not mutually exclusive. And we'll see that a bit later on. Okay, moving on to either red or a picture, part E. Here we go. So if we do exactly the same as in the previous one, we've got the probability it's red is 26 over 52. Probability it's a picture, 12 over 52, so our probability is 38 over 52. However, unfortunately, that's not correct. And the reason that's not correct is because if we think about the red cards, there they are, we've got hearts and diamonds, 1 to 10, then Jack, Queen, King in both suits. And if we think about picture cards, we've got hearts, Jack, Queen, King, diamond, Jack, Queen, King, same with clubs and spades. And you'll notice that what I've got is those cards there are in both sets. So they've been counted twice. So they were included as part of this 26, they were included as part of this 12. So in actual fact, they've been double counted. So when events are not mutually exclusive, when there is an overlap, because it is perfectly possible, as we can see, to get a card that's red and a picture at the same time, we've got to be aware of this issue of double counting. So what we've got to do is say, well, the probability of red or a picture is our two probabilities added together, and then we've got to take away the ones that have been double counted. So what we've actually got is 32 over 52 is the correct answer for that one, not 38 over 52. Right, so what we're saying is that those two outcomes are not mutually exclusive, i.e. they've got outcomes that are in common, and so if we take our statement from the previous slide, which was if two events are mutually exclusive, then you just add them together. If they are not mutually exclusive, then the probability of A or B is the probability of A plus the probability of B minus the probability of A and B. And already, hopefully, you should be familiar with kind of the use of the or and in terms of probability. There it is appearing again. So that was a quick run through of what we mean by mutually exclusive. Let's move on and have a look at the other term that I want to talk about in this video, which is independent events. So we've got unbiased dice rolled and find the probabilities, and already you're thinking, well, why is he forcing us to listen to all this stuff? Because clearly probability of 6 on the first roll is 1/6, second roll 1/6, third roll 1/6, i.e. that what you get when you roll a dice on the first go does not have any impact on what might appear on the second go or the third go or the fourth go. So we've got those probabilities are unchanging. As opposed to a situation where we've got now with red counts and blue counts, and again this kind of thing you'll be familiar with from GCSE. So we want the probability to get the red count on the first attempt, Well, clearly we've got 7 counters out of the 10, so that's going to be 7/10. On the second attempt, we've now got fewer counters in the bag, so we've only got 9 counters in the bag. There's now only 6 red counters in there, so the probability of getting red on our second attempt is 6/9. And on the third attempt, again, we've now got 1 fewer counter in there, 1 fewer of them is red, so we've now got 5 counters in there, and only 8 in total in the bag, so the probability is 5/8. The point being that the probabilities are changing. So what we're saying is in the dice experiment, the events are independent. The outcome of one event doesn't affect the probability of subsequent events, whereas in the counter event, clearly what you get first time does affect what happens next time. If we'd have got a blue first time, that would have affected our probability of getting a red second time, and so on. So it does change the probabilities, so the counter example is not independent. And really all I wanted to do from this video was just make sure that we're clear and we've got an explanation of what we mean by mutually exclusive and what we will mean by independent. We're going to look in a lot more detail about how that affects our probability calculations in future videos.